welcome to the Helix webinar series. Today's session is on what's inside the box. We're going to be covering BMC Helix Deep Container Discovery. Joining me today is our panel of experts. We have a few that will be in the panel answering questions, but for the main presentation, I'm going to welcome first Brian. Brian is our Principal Product Manager. He will be the first person to get the session started. And then we also have Adam, who will be presenting also some demos. And in the Q&A, we will have Duncan and we will have Matt and the team answering your questions. So before I hand over to Brian, who's going to start the agenda, the Q&A section of Zoom you will find at the bottom of your screen. If you have any questions as we go through the slides and the content, please put your questions in there. We will answer them during the session and also roughly have around 15 minutes at the end where we will take those questions to the live Q&A. So Brian, I know there's a lot to get covered today. I'm going to hand over to you to get us started.
Great, thank you, Sam, and thanks everybody for joining us today. So for the agenda, we will be covering, obviously, discovering containerized software, deep container discovery. What is it, and how does it benefit you? Then we'll have Adam do a demo of deep container discovery in action, followed by, okay, based on what you just saw, how did that all work? How do you set it up? How do you get it going? And then, of course, we can do Q&A at the end, but feel free to put your questions in as we go as well. So with that said, we'll cover what is it? What's deep container discovery? Well, what I want to remind everybody of is that we've actually been discovering containers and Kubernetes architectures for quite some time now. What we were not yet doing was discovering the actual containerized software, right? The software that was deployed in those ephemeral containers and relating that in the UI itself. So much of the diagram that you see, and really it's a screenshot of the visualization that you'll see in Discovery now as of the 25.2 release, much of this diagram already existed with the exception of the software inside the containers itself. But basically, we have extended the scanning that we do for SSH into the worker nodes, or cloud-based scans of the worker nodes themselves, the servers, and we've extended it to get into the container itself, and Adam will explain how we're doing that later. But getting into the container itself to understand what software is present, what the versions are, and so forth, and relating that in the model that you see on the right-hand side. What are the benefits? With this 25.2 release, we're essentially able to provide for asset management use cases. You have awareness of the containerized software details themselves, and you'll be able to then sync that information, for instance, over to the CMDB for your typical asset management or change management, ticketing, and so forth related to that software. And see how that impacts, what the impact is of outages perhaps within the Kubernetes clusters themselves. What I also wanted to call out is we also recently, if you haven't seen, automated the ability to scan Kubernetes clusters without having to manage separate credentials other than the cloud credentials you're already managing, and do that in an automated and efficient manner so that there's less overhead and you can more quickly get to, if I go back one slide, more quickly get to this architecture and understanding, hey, there's worker nodes to scan. Let's go see what kind of software is running inside them. And then finally, what are we doing? And Adam will get into this in the demo, we are ultimately creating what we call stable software instances. And these are just like any other software instance, regardless if it's software that we discovered directly on servers, or software that we, services that you are using in the cloud, for example. Now the containerized software is also just listed as a stable software instance, and it's from there that we would do synchronization, for instance, to CMDBs, and then in the future include in service modeling and things like that. So with that said, let me turn it over to Adam for a demo. Adam.
Yeah, so as Brian says, I'm just going to highlight some of the new features and show you how that gets into the UI, and then we're going to go into some details about how we actually make it work. So I'm going to start off with a quick search looking for some Kafka that I know we've got running. Got a whole bunch of software instances, and several of these, in fact, all of these are running in containers. And I'm just going to pick the top one and give it a moment. So this is a Kafka server that's been deployed into Kubernetes. There's a whole load of information down here. The visualization is quite minimal by default because it's trying to show you at a high level where that software runs. And this software is running as a result of a Kubernetes deployment. So it's just, that's where it is. It's not linked to a particular host because there are pods that are scaling out over various worker nodes. As part of the work that we've done, you can look at the details of all that containers, and that changes the diagram quite a lot. So if we drill into some of the detail, then we can see that we've got an instance of Kafka, which is actually made up of 3 pods or 3 containers that run on 3 different worker nodes. And it's this, as Brian was saying, it's this software model that's new in 25.2. Previously, we could identify these things, but we couldn't get enough of the details. We knew they were there, but it was hard to get inside the containers. So with the detail, you can see that it's saying that this stable thing has these 3 containers. And let's go and click on one of the containers below, which should. So we've shifted the focus of the model. Actually, I could have navigated that better to look at that contained piece of software. So this is the instance of Kafka that's actually running inside a container, and we can see that it's linked to this. It's actually a Kubernetes pod that it's running in. And we've got inside the container, we found out where it's installed and got all its versioning information from the container. And it's getting into the detail that is kind of interesting because that's how you find out whether what you're looking at is actually true. If you look at the container for this, well, it's a container and this is the information that it's telling you. And it interestingly has this container image, which if you look at as a human, I can say, well, yes, it's Kafka 2.7, and that's what we found, running on a Debian image. But if you then drill more into the details and actually get inside the container and find out what is deployed, it turns out it's not running Debian 10 at all. It's actually built on a Debian 11 image. So one of the ways of approaching containers is, well, everything will be found by the Kubernetes API, except it can only tell you image tags and things like that. And so without getting into the details of the containers, you can't be sure exactly what's running. And often you won't get patch levels and know what packages are deployed in terms of vulnerabilities and things like that. So it's quite interesting that the detail is there, but if you don't get inside the container, then you don't see all of those details. So the other thing, sorry, I've gone too far, let me go back. The other thing that you can find by getting inside the container is Kafka is actually running on, it's a Java-based system. So we've actually got a link to the Java virtual machine. So the runtime environments, which we discover running on the hosts, we can find those inside the containers. And so we know that there's a Java 11 VM running inside that container image, as well as the software, which is kind of invisible when you're looking at the container APIs. And so that's all of the low-level detail that we can extract. So I just wanted to pick up on what Brian was saying about the cloud scanning. So I did a bunch of scanning earlier on, and for example, here is an AWS scan that we did, and there's an automatic run that's been done from that, which is the Kubernetes. So this is an EKS cluster. As part of the Kubernetes scan, we've automatically found this cluster and gone and scanned everything that's deployed inside EKS. With AWS, there's a role with everything with AWS. You have to set up the correct roles, but with the role setup, it's all automatic. With some of the cloud providers, there's no additional setup and it just dives straight in. In fact, if I go and just go and find one of the other clusters, for example, I think this one. Yeah. So this is a cluster in Oracle that we've scanned. visualization is a little different with the cloud setups, but it's showing you the various worker nodes that are deployed. And if we drill into one of them, let's go into the worker node. Then we've got all of the pods that are deployed on that worker node. I don't know how visible that is, that's slightly larger. That are deployed, and the containers and everything else that are there, and that's automatically been collected just as part of the cloud scan. So there was no additional credential set up. It's just gone into the Kubernetes API or using the OCI authentication to pull out all of the data for that cluster and all of its deployments. I think that's kind of at a high level what I wanted to show. I'm just trying to move something out of the way. Yeah, that's just a different worker node, kind of showing you how the things are related. Okay, so do we want to go back to the slide deck, Ryan?
Yep. Let me share back out. Okay, so thanks for that demo, Adam. So let's get into how does that all work? So we'll get first into the container model.
Yeah. So as I kind of showed you there, there's the way that the model's evolved. Where we would traditionally have scanned a host and found the containers and the pods, we have now added these contained software instances. So this is the software running inside the containers, and that's what was running inside each one of those pods. And from that, there's one instance of Kafka running, regardless of how many of these containers you might have deployed across Kubernetes. And the reason we've done that is that the container software has a different kind of life cycle. And in fact, there's a question about aging in the Q&A. So with the contained software, the containers come and go. By its very nature, these things, one day you look and it's running on one node, the next day it's running somewhere else. And so we didn't want to create software instances that then age, and eventually you'd end up with all of your software running on all of the nodes in Kubernetes because it would need to age out at different rates. So we built the contained software instance model to more accurately reflect the fact that these things come, they run, and then they go away. And as soon as the container is gone, well, that piece of contained software doesn't run there anymore. But the stable software instance, or the higher level entity up in the top right here, doesn't go away just because of the container software is being deleted and moving around, because it's related to that deployment. We know that in my example, Kafka is deployed, and it's that Kafka that was deployed. And as long as that deployment still exists, then we know Kafka is still deployed in the cluster. So regardless of how the containers move, then the software remains stable. So your synchronization to the CMDB isn't affected by it coming and going and changing IDs and all of that stuff. And it will even handle the case with things like deployments where they can be scaled to 0 for doing node maintenance, where there is nothing actually running, but it still kind of exists as far as Kubernetes is concerned. So you can scale it down to 0, do the maintenance, scale it back up without adversely affecting the data in the CMDB. But it's to build this model is a kind of, you need both parts of the picture. So the Kubernetes API is very good at telling you about all of the resources that Kubernetes has deployed. So I've got this deployment, I've got these pods, which is a bunch of different containers running on hosts. But the information it knows about the container is it's an ID and an image, and the host, well, the host is an IP address and a host name or something. It doesn't have a lot of details. So that's why we've taken the approach of scanning things from the host, from the worker nodes, because then we get all of the detail that we can collect. We get much more information about the containers. And then from there, we're able to access those containers using the native tools to find out more information about the software that's running inside them. Okay, so if we move on, Brian. Okay, so a quick sidestep before we get into the details of how we actually do that. There's a lot of terminology when we're talking about containers. So people talk about Docker containers and they talk about Kubernetes. Essentially, there are kind of 3 levels of these tools. At the highest level are kind of user orchestration tools like Docker, Kubernetes, Podman, which isn't on this diagram. And those are the tools that typically we would interact with. But they really orchestrate how to set this thing up and then delegate running things to a kind of mid-tier, if you want to use that term, container runtime, which is typically containerd or CRIO, which is the Red Hat OpenShift runtime. And you can run containers using those tools directly. It's more tricky, which is why people use Docker or Kubernetes. But in fact, those tools are really about managing the image and setting up the environment to run a container, and they themselves delegate the actual execution of the container to a low-level container runtime like run C. There is another one called C run, very imaginatively named. And those are the things that actually run the container. And all of those tools kind of interact. And so it makes the process of detecting and managing, from our point of view, of detecting those containers running. If you ran a tool using Podman, well, you won't see it if you ran the Docker command, because Docker doesn't know about it. But if they're all using containerd, if you ran a containerd command, you would see both. And so we've revised how we do container identification to support additional ways of doing it, additional commands and things like that, so that regardless of which one of these tools you're using at which level, it will be able to identify everything, potentially falling back, if it lacks permissions or a tool isn't installed, because sometimes they're optional kind of user tools, then it can fall back to other methods in order to ensure that we find all of the containers. Okay, let's just move on, Brian. Okay, so how do we actually run things inside the container? And this is kind of the configuration step, is that we use a Linux tool called nsenter. Being technical for a second, that containers essentially are a clever use of a Linux kernel feature called namespaces. So a container or a set of containers can be in their own namespace, which is the isolation mechanism that's being used. And the nsenter command is namespace enter. And as the name suggests, it allows you to enter one or more namespaces and execute commands. And what's nice about this tool is that it's almost certainly installed in every Linux box you're ever going to find, so there's no optional tool. And it works with every kind of container. So regardless, from the previous slide, whether you used containerd or CRIO or any one of those tools, Docker or other low-level tools, at the lowest level, when the container is running, a container is a namespace or set of namespaces, and so nsenter will work. And it just avoids any complexity around, oh, well, you ran it with Docker, therefore I have to use Docker exec to get into the container. And it also has another advantage, is that because you're entering the namespace at the sort of Linux kernel level, you're not in, again, being technical, you're not in the same control group, which means that the commands and things that you do are run as if they're running on the machine, not as if they're being run in the container. So it doesn't impact things like pod resource requests and limits. So even if the command you ran consumed some CPU, it doesn't affect the runtime usage because it's not in the same control group as the pod. So that's kind of a really positive effect of this. With all of these container tools, the downsides, of course, are that you need privileges to be able to execute them. Certainly to be able to enter a namespace, you need to have either root access via sudo, or there is a way to do it with Linux capabilities. It's a little bit tricky to set up, but once you've done it, then you're able to do what you want to do. The other thing about using nsenter is, despite what I said on the previous slide about we can identify the containers in all sorts of different ways, this ability to run a command inside a namespace, inside that container, isn't actually dependent on us identifying the container using Docker or Podman or anything else. At the Linux level, we can see that that process is in a particular namespace. So when you want to execute a request, we know how to enter it to do the right thing. So that's the only setup that's required, is to ensure that the permissions are there so that that command can execute. Okay, so all of this work is very Linux focused. So we support Linux Kubernetes nodes, a variety of OSs and different runtimes, as we've said. There's currently no support for Windows containers. They're a bit of a different thing. I'd certainly be very interested to hear in anyone that's interested or using Windows containers, certainly in production. But although we've talked a lot about Kubernetes, it will also work with Linux hosts that are just running containers. So you've got a Linux host and you use Docker run and run a container. We would still be able to identify that as a container and run the requests inside it to get the right results. So it's not limited to just Kubernetes workers. It works with the freeform sort of Docker images or Podman in particular. Podman isn't a Kubernetes thing. It's its own kind of container runtime. So we can do that. And as I said, all of the container runtimes that we've encountered are supported. So everything that's deployed, we should be able to find. In terms of cloud, as we've said, because we can automatically scan the Kubernetes API, we've historically also been able to scan virtual machines inside inside clouds. So with AWS, EKS workers using the system manager sessions, we can get into those. GKE with the identity aware proxy. For OCI, for OKE clusters, we can get into them using the new OCI Bastion feature, which is in 25.2, possibly the earlier TKU. For other cloud providers, we can still get into the nodes, but they need either a public IP or need a cloud-based outpost. So for most of the major cloud providers, we can get into those worker nodes automatically, as well as Kubernetes. So you get both sides of the picture that you need to build the right model. The note there about Fargate, AWS Fargate, you don't get worker nodes. That's the problem with Fargate. It's all virtualized, and your Kubernetes doesn't run in quite the same way as it looks it runs. It doesn't have a worker structure. So there's no worker for us to access, and it's all managed by AWS. So unfortunately, Fargate is kind of invisible to us because there's no access from anywhere. So that's one limitation with AWS. Well,
thank you, Adam. So let's turn it back over to Sam, who can help us go through any questions that have come in.
Yeah, before we go into the questions, and I'm going to start unmuting people so they can ask us questions live. The other thing I just want to mention for those that have joined today that are in the UK, we do have the Helix Roadshow coming up. If you haven't already registered post-event, I will be sending you out the link. We're blessed to have the team that's on here today. Majority will be actually at the roadshow, and we've got a user group that's set up for discovery. So if you are in the area or you're planning to attend, there is a session that you can select, which is for a user group. It will be listed at the moment as roundtable. We would love to see some of you in person, and we also will be running other sessions that are going to be globally. There's quite a few in Europe. Those dates are on the process of getting released as well. So just to give you a bit of an insight, if you do want to meet with any of the panelists today, they will be there. So if we go on to questions, I can see Duncan was readily answering a question. So I'm probably going to ask Duncan to pick up Mike's question around integration with Harbour. While I go and unmute everyone. Over to you, Duncan.
Well, so I was actually just replying and saying, no, we don't have any current plans. And I was actually going to ask my own question, which is what is the use case for getting that information? I mean, obviously, so Harbour's a container registry or an artifact registry, but I guess in this context, it's a container registry where you would store the images. And obviously, you can get information from that if you wish. But I was wondering, I was going to ask what are your use cases for getting information from Harbour? What would you want to get from there that we don't get just by the mechanism that we already had and the new mechanisms that we've been showing today?
To get an SBOM off of the images, basically, and relate that to all the deployed containers from it.
Okay, that certainly makes sense as a use case. I mean, that's something that we have certainly talked in the past about integrating with container registries to get more information about container images. It's not something we're currently working on. Brian, from a product management point of view, might be able to say more, but it certainly, if we clearly, it's something that could be done. Technically, you as an end user, you could in fact do that. You could define a data source in Discovery, write a pattern that goes and does that. But if we see that as a common need, then clearly that is something that we could do as a standard Discovery feature.
Yeah,
if we get more feedback, that would be useful.
We don't plan on managing deployed ephemeral containers as far as like change management. We plan on having change management on the images themselves. So it really just pushing over that type of stuff to our CMDB wouldn't make a whole lot of sense as far as the deployed containers. We would want an inventory of all of our images in the CMDB so that we could, manage that be a change.
Yeah, I mean, maybe I wasn't so clear. The ephemeral kind of container software is not something that's synced to the CMDB. That's why there's back to the model, there's a stable software instance that's sort of the aggregation of all of those things. And it's that piece of software, let's go back to there, it's that would be synced to the CMDB, because that is something that it's not changing over time. Where it's actually deployed at any given instance is changing, but that piece of software, be it a version of Kafka or Redis or whatever, is a stable thing. And that will update. Obviously, if your container image, if you updated it and it went from Kafka 3.7 to 3.7.1, then your stable software would update, and that would be synced to the CMDB.
Yeah, right. So it's probably
that's an extension. Sorry, go on.
I was going to say it's one step removed from the image, right? Where this software instance up here, which would be stable and represented, that's where we would sync to the CMDB. But it's kind of one step removed from the image that I think that you're talking about.
2 steps, but
sure. There's
two, yeah.
Well, yeah. So there's actually 2 different things that we're talking about that are clearly related to each other, but not quite the same. So first thing about the CMDB, that even prior to this deep container discovery work, it was already the case that software container nodes from discovery are not synchronized to the CMDB because they're ephemeral. The CMDB is about the things that are under change control.
Yeah.
And as you say, the software containers are not. Now we're saying inside this container is this piece of software. Well, that obviously is also not in the CMDB because it's not under change control. Whereas the deployments which are related to the images, they are. Now, the 2 similar things that we're talking about are that container images have information about them, and as you say, talking to registries like Harbor, you can get potentially more information about what the meaning of the image is, and that's certainly an interesting avenue to explore. And that information could hypothetically belong in a CMDB, but it's not something that's out of the box pushed into the CMDB. The other thing we're talking about, though, is this new functionality which allows you to look at what's actually executing inside the containers. And that clearly relates to the container images, but in a way it's more direct in that it's more precise. It is what's really actually executing inside the container as opposed to what the metadata out the image says is in the container. So if you're very rigorous about naming of your images and the metadata out the images, then you're good. This, in a way, allows you to check up on your understanding of what's in the images because it lets you see what software is actually there and not just the products that are the software instances. Because Adam says in his example, there was a Java runtime environment where that has a version. It doesn't just have a version, it also has a vendor, and if the vendor is Oracle, maybe you care from a license point of view as to the fact that it's there. And so that information we're getting with the deep container discovery that you don't directly get from the image. You have to trust the metadata about the image if you don't have the discovery of it.
Well, I've already looked at some of this data in our discovery tool, and for example, we have native containers that get deployed with I forget what they're even for, but they have Apache Tomcat. There's some Apache Kafka and Tomcat software instances that I see created off of them. The issue is it's unable to pick up the version. It just sees Apache Tomcat without a version populated.
I assume you mean you're using a previous version of Discovery without this deep container discovery.
Oh, probably if this is brand new, probably.
Yeah, this is brand new. So yeah, so
okay.
This is the thing that before this functionality came along, then Discovery, when it's scanning a compute node or as a Linux host that's just running some containers, it sees those processes executing, but then in order, for example, to get the version of something, it often needs to run a command or read a file or look at various other information. And prior to this release, the system did not understand that this thing is in a container, and therefore when I run a command, I need to run a command in the context of that container. Or when I read a file, so I look at a path of /user/local/whatever, that is not the host's path, that's the path in the context of that container. And that's the new functionality, that it understands how to run those commands inside the context of the container, get files from the container and so on, which means that you get the right answers rather than either no answer at all, or even worse, the wrong answer, because you run a command, you run Tomcat -- version, but it's the Tomcat that's installed on the compute node, not the one that's inside the container.
And that's what we've seen. Thank you.
Got another question in the Q&A from Kanika. How is compliance being taken care of with this functionality?
I don't know if we might need some more clarification of the question, if Kanika can come off mute.
What I mean is this, can you hear me?
Yes.
Yeah. So I was going through this and it said that the capability supports governance, compliance, and the operational efficiency. So I wanted to understand it more what it means.
Kubernetes compliance. Are you talking about something you saw in the documentation?
It was just on the not in the documentation. It's in the session where you
It's
have
it's in the description of the
yes.
yeah. But yeah, I mean, I can answer that in the sense that if you're asking where's the compliance management feature, that's not what it means. That discovery, so in general, discovery's data is used for compliance purposes, by which we mean that there is a wealth of information about the things you have deployed in your environment, which helps you to analyze outside of discovery, are you compliant with whatever policies you have? So back to the example of Java runtime environments, if your policy is we will not use Oracle Java, are you in compliance with that or are you not? Now, this feature for deep container discovery allows you to extend that information to software that's executing inside containers. So previously that was somewhat invisible, with the caveat that, as we say, sometimes you saw certain aspects of it, but it wasn't properly interpreted. So it supports compliance activities. So it's not that we have a feature that you can't go to the compliance console or something like that. That's not a feature that Discovery has. What Discovery has is a wealth of data that helps you with your compliance processes. And this is about giving you more data to help with those compliance processes.
And
that's something.
thanks. I was going to add to that real briefly. Thanks for that, Duncan. Is I think it also supports lifecycle management processes
Yeah,
as
that's
well,
what
right?
my question. Yeah.
Exactly. Especially with the version information, and then we already are enriching a lot of this software that we discover with end of life data, and so that would apply even for software that we see inside the containers themselves, right? If that's covered by the end of life data.
Okay. Yeah, this is what I was wondering with the end of life data. Okay.
Yeah.
One way to think about what we're enabling with this deep container is none of the information is anything different to what we previously had in Discovery. It's just we've extended the scope of it such that we can tell you those things for software executing in containers, whereas previously it was either partial or non-existent, that information. So it's the same information we get if I'm running a piece of software just running natively on a host. We will now be able to give you the same kind of depth of information about that same piece of software running in a container where previously we could not. So there's nothing new. It's just newly available for the context that it's in a container.
Which is a good additional point, is that we're actually leveraging all the decade or so of existing software patterns. We're still using all the same software patterns for discovery. We're just now knowing how to get at inside the container itself to run those commands. So
I think that's worth pointing out. All of what I showed earlier is using all the existing TKU patterns. There's no real change to any of those patterns to make all of this work. It's all kind of automatically done. So if you've developed your own patterns to go and retrieve software, if it's now running in a container, well, it will automatically do the right thing. There's not a load of work there to re-implement all of that work.
Right.
Okay, thanks.
Thank you for your question. Okay, we don't have any other questions, but we'll just open up to the floor. Does anyone else have any questions for the team? Just as I said that, Mike, I saw what version supports this?
It's 25.2 for the on-prem appliance, which is already out. That came out earlier in June, and it's 20. Andy, keep me honest here. It's 25.2.02, which should start pushing to the dev instances in SaaS in early July.
Yes, that's correct. There was an earlier question from an attendee about whether this was available for both SaaS and on-premises discovery, and the answer then and here is yes, it is.
Yeah.
Okay, do we have any questions from anyone else?
Hey, Samantha, this is Eric Herman. Brian and Adam answered a question I was typing regarding the patterns and, the leveraging of the existing TKU patterns. Is there anything required to to flag a software instance or as contained, or is it just recognize that this discovery is happening at that layer and that's how those nodes are then modeled? So I'm thinking forward to if we end up creating custom patterns, if there's anything new in the pattern logic that will recognize that we would need to include in those custom patterns.
No, it is automatic. Behind the scenes, the system kind of has the concept of a context. It knows the context in which the pattern is executing. And if the trigger and some other conditions mean that it's a container, it's a contained piece of software, then it will automatically create the right kind of node regardless. So taking the Kafka example, the pattern says, historically you see Kafka running on a server, well, we'll create a software instance running on the server as we always have. That same pattern without modification, when it triggers on the Kafka process, is in a container, the pattern still says, well, I want to model a software instance, but the system says, well, actually, no, that's a container, so I need to do the right thing and change things around. And the propagation of the stable software instance is all automated. And there are some extra facilities in the latest version of the pattern language to allow you to control that if you've got special cases. But the default will do what you want. It's only in the special cases where actually it is a container, but I want to do something clever or different, then you've got mechanisms to control it.
But yeah, one of the design principles that we started with, which was we wanted to make sure, precisely to you for your reason, Eric, that the customers weren't burdened with having to know all of this stuff. And also selfishly, we didn't want to have to burden our own TKU team with a whole bunch of work to rewrite or extend all their existing library of patterns to account for this. So that's why the internal system magic was added.
I think I appreciate it as well. Thank you.
Yeah. Just to add to that, something that at the moment we've talked about software instances. And so, yes, as we say, there's some magic that says if you create a software instance, so you have a pattern that says model.software instance to create a software instance, it will actually, the system will now not do that. It will create a contained software instance if the context says it should. And then the system will automatically make the stable version for you related to the deployment. But it's more extensive than that, in that certainly many TKU patterns and your custom patterns as well can do things like, for example, we can spot this software instance is a PostgreSQL database and it contains some database nodes, or it's a Tomcat, to use the earlier example, it has some software components in it. Now, those things get created by patterns, sometimes the same pattern that started, sometimes another pattern. Those things automatically get related to the contained software instance, but the system understands that they're probably not the ones you want. So if you're searching for databases, you don't find those by mistake, but then the system will automatically bubble those up to the stable software instance that's inferred from the stable ones. And so the full and comprehensive model in terms of all of the structure underneath the software instance, that is automatically maintained in the stable software instance without the pattern having to do anything about that. So it's not just software instances. If you've written custom patterns, then basically everything it does will automatically be handled in this new world.
There's a question from Derek that he's asked. Maybe we should answer that one live as well, because it's possibly a lead into some of the things you want to talk about, Brian, in terms of features. But Derek Phillips asks, are there any limitations to what can be discovered or any further developments, improvements being looked at?
Well, I'll quickly cover the things we talked about before, Brian. I think, as I said, it's Linux only. So if there are other container technologies, that's a minor limitation. One of the other things that's a particular challenge is what's called distroless containers. So if your container image is particularly pared back, it's literally just the application running in a completely bare container, then there's no way to get into that container and run things because there is nothing in it to run. It's just the application. And so they become a bit of a black box. Having said that, we can still find out quite a lot of information, but for example, you can't easily run things like retrieve files and things like that from inside the container because there's no commands to run to do so. And that's something we're continuing to work on. So while it's a limitation currently, there is some plans to things we might be able to do with that, certainly with Kubernetes. Brian, I'll let you talk to the other things.
Yeah, I think the main thing, and just to follow on some of the benefits that Duncan outlined earlier with respect to the approach that we've taken in scanning what's actually deployed, as opposed to just looking at the images and the benefits of what we think doing it this way. Additionally, the next step for all of this is to then start to build and discover the relationships to and from this containerized software. And of course, the big use case around that is in support of AI ops and service modeling. So today we're doing the asset management use cases. We know that this containerized software is out there to the earlier question, lifecycle management of that software and so forth. And version control of the software and so forth. But the next big step would be relationships that you wouldn't obviously get from just looking at the image repositories and things like that either. So that's the ultimate goal, and that's where we're heading next.
Okay. We've got another question from Lars. Is there anywhere where we can talk about how this is reflected and used in CMDB in a more elaborated format? Andy, another question I see you posted as live.
But I thought we might as well answer it
Yeah.
live. I expect Duncan may be the one to answer it, however.
Well, I would like to answer that it's part of our documentation of so we have an extensive documentation that documents the CMDB synchronization mappings, as in how things in Discovery's data model are mapped into the CMDB. I hope that this new information we have is reflected in that documentation. I'd have to go and check to be 100% certain, but I'm fairly sure that it is there. If it's not, we should fix that immediately. So I think that's probably what you mean, is just how does the data appear? To give a very brief answer, the answer is that, as we said before, the actual containers, so the software container nodes that contain software instances, they've never been pushed into the CMDB by default, so they continue to not be pushed into the CMDB. But the stable software instances, they are now synchronized into the CMDB, and they're related to the deployment. Well, the deployment nodes get mapped to a CMDB concrete collection, which is a weird sounding name of a class, but that's the class that's used in the CMDB for that. So you will see the software servers related to a concrete collection that represents the deployment, but that, as I say, that it should be in the documentation. I hope it is. If it's not, then obviously we'll fix that.
Why we just give people a few minutes to think. I don't know, Brian, from a wrap-up standpoint and for the rest of the team that's on here from BMC Helix, is there any call to actions, any kind of reminders or getting started that you want to just share?
No, thanks, Sam. I think certainly if there are more questions, I think hopefully you'll know where to reach us or contact us by way of your account teams. We're happy to answer questions. We are encouraging everybody to give us feedback, right? This is a big new feature. If there are things that we should consider or things that you'd like to see improved beyond what we've released here in 25.2, then that's what we want to hear about. I already mentioned, where we're probably taking this next. I shouldn't say probably, where we are taking it next in terms of relationships and feeding into service models for AI ops. And we do have, I think, Sam, you were going to remind, but I'll steal the thunder there. We are having a roadshows throughout the different regions. And the next one up is in London. So if you're going to be in London or would like to be in London on July 17th, there's a great agenda from an overall BMC Helix perspective. But as part of that agenda, we do have some time set aside for a discovery user group where we did want to talk about and get feedback about this feature in particular, deep container discovery, but where we're also planning to talk about and get feedback around service modeling in general, as well as understanding what your all ideas might be around the use of AI in discovery and some ideas that we have as well. So, and then of course, any other topics, the intent is almost like a roundtable type of open discussion. So it'd be great to see some of you at least in that event in London, again on July 17th, and perhaps coming to another roadshow near you.
Thanks, Brian. I know I briefly mentioned it at the start, but I will share out the link for those that don't have access or know where to start with that. And you'll see when you put your registration in, it will give you options of which sessions you'd like to run or even attend. Great. And Kelly, I can see you've popped your question in. You did say you need to write it down. So Kelly had a question for everyone. If there is a 0-day that exploits elements within the container, what options do we have to mitigate it as quickly as possible to protect our environment beyond the application?
Well, maybe I can answer that in a minute. Again, it's the same kind of answer I gave when we were talking about compliance, which is that Discovery itself does not do any mitigation of security vulnerabilities. It doesn't try to patch anything. It doesn't try to remediate anything. But what it does do is it gives you a wealth of information to help you understand your exposure to whatever this issue is. So again, the knowledge that, okay, there is a particular product or a particular component that is vulnerable to something that we care about, we now give you better information about all the places that that is present, because now we can see inside the containers where previously we had a much more superficial view of what's in containers. So again, Discovery is not in the business of remediating this stuff or minimizing the impacts of things, but it's in the business of giving you useful data to help you do that using whatever other tools you have. And this expands the scope of that information it gives you.
Thank you, Duncan. Hopefully, Kelly, that's answered your question. If you can just let us know. Oh, can you hear us, Kelly?
Yeah. Oh, can you hear me?
I
Yeah.
can, or we can. Hello.
Oh, okay. Okay. Well, I was going to type my answer, but okay. Not really, but I understand what you're saying.
Are you saying you'd like Discovery itself to be able to
No,
mitigate?
no, that's not what I'm saying. I'm not saying that. I was wondering that my question was about the containers themselves, in terms of not how discovery impacts them, but whether if a 0-day comes that exploits the containers or an element or elements that's inside the containers, what options do we have um, to mitigate them? And specifically, like, we have a containerized product for Helix.
Are you talking about 0-day of the Helix against the Helix deployment itself?
Yes.
Okay, yeah, that's I think completely separate topic, right? That's just a question, I think, of how do we maintain security and security best practices of the SaaS environments, which I think we could probably just take offline. But I think if that
Okay.
makes sense, if that's your question. Yeah.
Yes.
Okay. We can follow up offline.
Okay. Thank you.
So,
Okay.
so there's one more question from Mike, which I might as well answer, which says, will this end up creating candidate software instances for custom applications? Will it be able to see custom web apps running in pools inside a container? Well, that's several different things in one. So can it identify custom applications? Can you use a pattern to identify custom applications? Can you, if, for example, you've got a Tomcat application server and it's running some custom web apps inside it, can it see those? The answer to all of those is yes. Right now, the answer to the first part of the question of will it create candidate software instances? Right now, the answer is no, but that relates to what Brian was talking about, which is that at the moment, just in terms of sequencing our activities, the first thing we've released is the understanding of the software that's executing in containers. We've not yet implemented the working out dependencies between bits of containers. Now, dependencies means many things, and in fact, some dependencies you do get kind of as a side effect in the sense that you can have situations where something reads a configuration file that tells you about a database that something's using. It will go looking for the database, it will find it, link them up. That works. But one of the big things that we do for non-containerized software is we identify observed communications where you basically say this piece of software executing is seen communicating to all of these other things. And it's part of that the system design builds candidate software instances that says there's a process or a group of processes executing here that are not part of a software instance, but they look like they're interesting based on their communication profile. That's what a candidate software instance is. And so for the moment, we are not yet digging into the network connectivity, and therefore we're also not yet generating candidate software instances. But once we do get down that path, then yes, we will be doing that. So right now, no, you won't see any candidate software instances, but it's not because you never will. It's because that feature isn't there yet. I hope that made sense.
Okay. We've got another question from Eric. Are CMDB nodes flagged as cloud or some other indicator of being container-based?
I assume you mean the stable software instances that are related to the deployment. So they're not flagged as cloud because they're not necessarily in the. Sure, it might be a cloud-based Kubernetes, but it might be an on-prem one. So it would be wrong to say that they are cloud. But you can tell because they are related to a deployment as opposed to being related to a computer system if it was a normal software server. So there's no attribute value on them that indicates that they're that they're the stable software instance from a container, but you can tell from how they're related to the rest of the world.
Okay. Yeah, the scenario I was thinking is if someone were to go in and just search for Kafka, for example, being able to differentiate those that are, based on traditional server workloads versus within, the Kubernetes environment.
That certainly makes sense. But as I say, at the moment, so there's no specific field in the CMDB that could be used for that. And it would be wrong to call it, say it's cloud because, well, it might be not. But yeah, so for now, the answer is that you would have to look at how it's related to things. And I know that, so in Discovery, that's trivially easy. In the CMDB, it's slightly less convenient to look at how things are related to each other. But that's
Sure.
the answer.
And another CMDB related question would be just based on your development and testing, is there an expectation that we may see a significant increase in the number of software instances that we will be ultimately discovering and passing over to the CMDB under this approach?
Clearly, there'll be an increase, but not a very significant one in the sense that.
Actually, there might not be an increase. There might be a decrease. If you look at the model here, previously we would have probably created 3 software instances for the 3 containers, which were software instances on the host, which would be synchronized. Now we're only creating 1 for all 3 of them because we know they're containerized, and it's only that one that will be. So it shouldn't create significantly more, and in fact may actually synchronize slightly less.
Okay,
yeah, that's interesting. That's a good point. So you'll have new ones that are related to the deployments, but as Adam says, actually in the past you might have had, in a way, kind of accidental ones in the sense that they were not very good quality. They were not necessarily completely correct in their data that has come from the containerized software. So yes, you might find the absolute number decreases. The number that are most useful to you will increase a little, but not by a great deal because it's going to increase by the number of deployments you have as opposed to the number of containers that you have. So if you have some big horizontal pod autoscaler and you've got 100 instances of something, well, you're going to have 1 software instance for that because that's 1 stable identity with 100 contained software instances which don't end up in the CMDB.